A for this question there. We said your first task is to always label the capacitors C1, C2, and whatever. So I'm starting from here. I'll call this C1, I'll call this C2, I'll call this C3, I'll call this C4, I'll call this C5, I'll call this C6, I'll call this C7. So case 1, let C1 be equal to this C2 be this, C3 be 3 microfarad, C4 be 5 microfarad, C5 be 6 microfarad, C6 be 5 microfarad, and then C7 be 4 microfarad. That's the first case. Now we said let's use circuit reduction as we did in the last class. Your first case, if you're here, please, let's walk through that please. If you're here, please, let's walk through that please. Take down. Have you sketched this? Have you sketched this? Let me know. Yes. Take down please. Take down. Observe that C1 and C2 are in series. Observe that C1 and C2 are in series. Hence, their equivalent is given by in series. So you take inverse. So it's given by, so C1 and C2 in series. We said equivalent. Now listen, I told you that you only add CEQ when you're doing the last capacitance. For this one here, C1 and C2 is not the last one. So because one there, C8 instead. From C7, just add C8. So 1 over C8 is equal to, for series, 1 over C1 plus 1 over C2. That's equal to 1 over C1 is 4 plus 1 over C2 is 10. I have this. Right, C1 is 4, C2 is 10. 1 over C8 is equal to, my LCM has 40, I'm having 40 over 4, 10 times 1, 10, plus 40 over 10 is 4 times 1 is 4. That's equal to 14 over 40. So hence I have 1 over C8 is equal to, the lowest term, 2 here, 7, 2 here, 20. That gives you 7 over 20. Hence, C8 all over 1, which is same thing as C8, is equal to 20 over 7 microfarad. Don't forget, it's in microfarad. Using circuit reduction idea, we said draw the new circuit. For the new circuit, I'll have this. Now, yesterday, I just resolved these two here. If I'm going to put sitting here, go to my class. So I just resolved these two here in series, meaning that these ones are still intact. So we said for circuit reduction, I'll still reproduce my diagram. So reproduce this one here, but you resolve these two. So I'll now be having from here, I'll now be having this straight line, this one. So I'm having this one here. This 1, 2, this one here. 1, 2, this one here. Okay, put one there. Alright, so next up, this. Alright, so this was 4 microfarad. This was 5, yeah. This was 5 microfarad. Up here was 6 microfarad. Here was 5 microfarad. This point here was 3 microfarad. Now let's be, don't forget, I'll resolve this to here. Resolve this to here, they give us C8. So hence, this part now becomes your C8. So C8 comes here, and we said C8 here is 20 over 7 microfarad. We call this C3. So this was C3. This was C4. So this one here was C4. This was C5. So this one here was C5. We call this C6. So here was, let me bring this back here. So I'll change this. So that will now be equal to, so this is step 1, this way, step 2, this way. That gives you here, this 1, 2, this comes down, 1, 2, comes down this way, that goes like this. So look at it. I have this one here. This one here is still intact, 4 microfarad, so 4 microfarad. This one here is still intact, that's 6 microfarad. This one here is still intact. Excuse me, I have this. Alright, this one here, 5 microfarad. So I have to look at it, look at it. We call this C7, so this was C7. This was C7. We call this C5, so this one here was C5. We call this C6, so this one here was C6. Now observe, what I resolved was just 1, 2, 3 in parallel, and I had my answer, which I called C9. So C9 will now come here. So C9 is equal to 76 over 7 microfarad. So I have this. What's my next task? Look at it. If I look at this now, this one here looks like this one I just worked on. I would say the idea was we added this and this in series first before 1, 2, 3. Same concept here. So that means I'll now add C5, this and this in series. So hence taking C5 and C9 in series. Is there any question, please? Any question? Taking C5 and C9 in series. If I find the equivalent for C5 and C9, observe that my answer will not be my total equivalent because I still have these two to work with. So hence that will now becomes what? It becomes C10. So I have that 1 over C10 we said for series. Yeah, take inverse. 1 over C10 is equal to what there? 1 over C5 plus 1 over C9. That becomes 1 over C5 is what? 6 plus 1 over C9 is what? 76 over 7. I have this. Alright, so all over this one here. So from this line becomes 1 over C10 equal to 1 over 6. Now for this one it becomes plus. We said when you're doing inverse, all this one here, upside down. For this one here, you will now swap position. So this one goes upside down, becomes 7 over 76. So 7 over 76. And that's equal to, please, if you have the white calculator, please punch. Give me this value here. You see the stress. Just punch this. What's the answer? What? 4, 5, 6 over what? 118. Please confirm. I'm going to confirm this correct. So we have this one here, right? Hold on now, this one is correct. Wait now, add up these two first. What do you get? Carry white calculator for me. 1 is what do you get? 59 228 like this. Alright, so from here, what's it there? Invert that. That means 1 over sec there is equal to what there? 59 over 228. From here, just invert that. Sec 10 over 1, which is equal to sec 10 is equal to what there? 228 over what there? 59 microfarad. So turn that upside down. Sec 10 is the equivalent of these two arranged in what there? Arranged in series. So from here now, get out the next circuit diagram. Now be equal to, don't forget I've resolved this and this. So hence, reproduce these ones here, then get equivalent. So it becomes the same diagram again. From here, goes this way. This. Okay. Becomes same diagram. Goes this way. This, here. This. No, we got this one already. Sorry. So my third step, my step 3, these two are the result. So here is now flat, okay? This, 1, 2, this. Here. Alright. This one coming this way. Here, 1, 2, comes down. We call this 4 microfarad. This is 4 microfarad. This one comes down this way. It's going down this way. This and this going down here. This value here is 5 microfarad. So I have this as 5 microfarad. This one here, look at it. This one here is the equivalent of these two in series, which is C10. This was C10, which we got as what there? 228 over what there? 59. Of course, in microfarad. This one here, we call this C6. No? We call this what? C6. Right. We call this C6. We call this one what there? C7. Observe. If I now look at it, if I now resolve 1, 2, 3, that becomes my total capacitance. So it becomes what there? CEQ, my final stage. So finally, I'm now saying taking this C6, C7 and C10 in parallel. So taking C6, C7 and C10 in parallel. Of course, for parallel we say simply do what there? Add them up. Now here's the observation. If I take these three in parallel, that's my final equivalent. So now is what here now? CEQ. So hence the equivalent capacitance is equal to C6 plus C7 plus C10. That's equal to C6 is 5 microfarad, C7 is 4 microfarad, C10 is 228 over 59, also microfarad. So CQ is equal to, add this to have 9 plus 228 over 59. Let me really work and solve this thing here. So please give me this answer please, as a fraction. So CEQ is equal to, what do you have? Fraction, what do you have? 759 over over 59, of course, in microfarad. So this is your answer. Give me as a 2 decimal place, decimal number. What do you have? In 2 what do you have? 12.86 microfarad. So that's your equivalent. That means step 4. My final step 4. I'll now combine 1, 2, 3. You'll now be having something of this nature. This, like this, yeah. 1, 2. This here, you have this. So it becomes this one here. So observe this one, 1, 2, 3. My final one becomes CEQ. CEQ here. CEQ. We said is equal to 12.86 microfarad. So this is how you get your stuff. That's how you solve this stuff here. That's the answer. Let's look at the B part of this. B part of this. Look at this. B part says, also find the total energy stored by this network of capacitors if it is connected to a cell of 25 volts. Find B part says energy stored. Energy stored in the capacitor. It said the voltage V is equal to 25 volts. Find the energy stored. Look at this. Look at this. So, here's what to note, please. Energy stored in the capacitor is represented by U, and U is equal to half QV. So you have half QV. But from our formula in the last class, we said Q is equal to what there? It's equal to CV. Q is CV from our last class. So hence, U will be equal to what there? Half into Q. Q itself is CV. So half Q, that's this times V. Such that if I multiply, it becomes what there? Half CV squared. So that becomes the formula I will use to get the energy stored in the capacitor. Don't forget, it's either half QV or half CV squared. I should have used half QV, but observe, no charge given here. There's no Q here, no charge. So hence, I'll improvise to using CV squared. This C here, obviously, is C equivalent. Of course, then V, I'm doing V as the 5. So let's use this formula and get the answer. So, U is equal to half CV squared. U is equal to half, yes, of course, that's equal to half, in this case, is C equivalent, then V squared. It becomes half. C equivalent is this here, 12.86. Don't forget, it's in micro. Micro becomes what there? 10 power minus 6. And then V squared. V, we said is 25, becomes 25 all squared. This will be equal to, please give me everything there. Give me this to power minus 6 times 5 squared. Give me all of this as numerical. What do you get? Please first give me this one here times 25 squared. What do you have? What do you have? 8.037. Is that all? times 2 power what there? Minus 3. Alright. All over 2. Please answer over 2. U is equal to what you guys? 4.0. That's 4.02 now, right? Okay? Times 2 power what there? Minus 3. Energy is measured in what? Joule. So become joule. 10 to the power minus 3 is called what there? Milli. So this is equal to 4.02. 10 to the power minus 3 is milli. So it becomes a small n, the capital J. So hence, the energy stored in the capacitor is 4.02 millijoule. So that's how you solve this question. That's it.